Okay, in today's lesson, where you can see by the title, we're actually going to be proving that a quadrilateral is a parallelogram. So up to this point, we've been solving problems and we've been using parallelograms and all their properties. But today we're going to kind of flip it. We're going to say, how do you actually prove that something is a parallelogram? So it says in our targets, I can define the 5 different ways to prove a quadrilateral is a parallelogram. And then I can use those obviously to prove that it is a parallelogram. So let's remember what we know. If you think back, you've been using those properties a lot the last few days. Hopefully just the word parallelogram reminds you that opposite sides are parallel. So we know that opposite sides parallel. I believe we know something else about opposite sides, right? We know opposite sides are congruent. So I can mark that. Think about that word opposite. We know something else about the word opposite. I believe we know opposite angles are congruent. So those angles and those angles are congruent. Think more about the angles piece, right? Opposite angles are congruent, but what do we know about consecutive angles, like these two angles or these two angles, right? I believe consecutive angles are supplementary. And there was one other one. This is the one we tend to forget a lot. A property that we had is that the diagonals actually bisect each other. That's why I have them drawn in there. So bisect would mean those two would match and these two would match. So I'm going to say diagonals bisect each other. Those are the properties we're going to use to develop these theorems, right, that we can use to prove a quadrilateral is a parallelogram. So obviously the easiest one comes from the opposite sides parallel. That's right out of the definition. We're just reversing it. So if, and notice it's both pairs of opposite sides parallel, we could say we have a parallelogram. Again, that's just right from the definition. Similarly, we can do it with congruence. So we could say, and again, you have to have both. That's why I'm underlining that word. If both pairs of opposite sides are congruent, then you have a parallelogram. And we'll keep building off of that opposite, right, with the angles. If you have that, you also have a parallelogram. And again, it's both. Both pairs of opposite angles congruent, then you have a parallelogram. All right, so the two we haven't used yet are consecutive angles and the diagonals. So let's flip the page and let's add those to it. All right. Now for consecutive angles, we're not going to use that one per se. We're going to go right to diagonals. I'm going to say if the diagonals bisect each other, then it's a parallelogram. So that's number 4. So the consecutive angle one does not really give us much. The consecutive angle supplementary would cause those opposite sides to be parallel, and we already have that one. If opposite sides are parallel, it's a parallelogram. So the question is, where does this 5th one come from? I'm going to put a star here, right, because it's the one that we kind of forget, but it's often very useful, right? I'm going to draw it for you first. If I have a parallelogram and I have one pair of sides parallel and I have that same exact pair congruent, that's going to be enough to say it's a parallelogram. So I'm going to say if one pair of opposite sides is both parallel and congruent, then you have a parallelogram. Common mistake, it has to be the same side. So I can't have these two parallel and these two congruent, right? It has to be that same exact pair, has to be both parallel and congruent. So it can't be one pair is parallel and the other pair is congruent. All right, let's look at a couple of examples. We are given a parallelogram. ACDF is a parallelogram. we are given AFB congruent to ECD. Let's find those. AFB, mark your angles carefully. ECD, that's those two. That's all given. And I'm going to highlight the parallelogram, right? This was in the given. So where is the parallelogram? That's the big one. So the green one, that's the one I know. That's the one I can use parts from. I'm trying to get this guy to be a parallelogram. I'll color that one in. So the yellow is where I'm headed. The green is the one that I have. So I can use properties of a parallelogram from the green one, and I have to decide how will that help me get the yellow one. Well, properties of a parallelogram. Opposite sides congruent, perhaps, right? I could get AF. I'm looking at these angles, so I'm kind of leaning towards those triangles. I could get AF congruent to CD. If parallelogram, then opposite sides congruent. Well, then I'm pretty close to getting these two triangles. I'm not sure how they help me yet, but it seems too good to be true. So I'm going to choose opposite angles congruent, because then I know I can get my triangles congruent. Angle A congruent to angle D. If parallelogram, then opposite angles congruent. And then I'm going to get triangle FAB, triangle FAB, congruent to triangle. That would be CDE. That would be by angle side angle. Now then the question is, what parts of those are going to help me get this yellow guy congruent? Well, I have a lot of options, right, on how I prove a parallelogram, but the most glaring one to me is that this side right here from this triangle is congruent to EC right here from this triangle. That's a pair of opposite sides. So I'm going to say that first. I'm going to say FB is congruent to EC by if triangles congruent, then opposite sides are congruent. All right, well, now we've kind of narrowed it down. If you look over your ways to prove a parallelogram, and we have a congruent side, that means we're either going to use this one pair of opposite sides is both congruent and parallel, or we're going to use the one that says both pairs of opposite sides are congruent. So I either have to get these two parallel, which I'm not sure I see that right now. I'm not sure where I have angles that would really be useful. Or I have to somehow get FE congruent to BC. Well, I know from the green parallelogram that I could get FD congruent to AC. That's from the green parallelogram. So I'm going to add that up here. Opposite sides congruent. I can get FD congruent to AC. Do you see how that's helpful? How are FD and AC going to help me get FE and BC? What else from these triangles would be useful? Can't I get AB congruent to ED also by, and why did I say opposite sides congruent? If triangles congruent, then, I'm just looking at my work here, corresponding parts are congruent. Sorry, so now I'm back here. I have FD and I have AC, right? If I choose AB and ED also as corresponding parts, AB congruent to ED, now I have overlap, so I can subtract to get FE congruent to BC, and I would say if congruent segs subtracted from congruent segs, then the differences are congruent. So again, from these two triangles, I use these two sides, which are corresponding parts, and I also chose these two sides, which were corresponding parts, which I then subtracted from the green sides of the parallelogram that I knew opposite sides were congruent. So now I have this congruent to this. So now I believe I have reason number 2 that we listed there. I can say that yellow guy, FBCE, is a parallelogram because if both pairs of opposite sides are congruent, then I have a parallelogram. Okay? All right. Here's example 2. I have triangle CAR is isosceles, and the base is CR. I have AC congruent to BK. Let's mark that, AC and BK. And I have angle C congruent to angle K. Angle C congruent to angle K. All right, so I'm trying to prove, let's color it in again, that BARC is a parallelogram here. This guy right here. All right, that isosceles, how can I use that, right? If CAR is isosceles, well, I know that CA should be congruent to AR. If isos, then I have two congruent sides. But when I go to mark them, I realize this one already has a mark. So when I mark it the same, do you see the transitive? If AR matches CA, but CA matches BK, can't I get these two congruent? Let's say that right away. So that means I get AR congruent to BK. You can see the transitive here. Well, that's pretty good because now I have a pair of opposite sides congruent. Is there any way to get AB congruent to RK? I don't see that yet, right? That would be both pairs of opposite sides congruent, just like we used. Or, hint, hint, look back up. If we can get one pair both parallel and congruent, we'd also be in good shape. Well, we have the congruence, so is there any way I could get this parallel to this? I see a transversal, right? And you know to get parallel lines, we need angles. Well, when I color in that F, right, or those green lines, I see an F which means corresponding. That would be these two angles, but I don't know anything about this angle. Oh, but I do, because it's an isosceles triangle, so I know this angle is congruent to angle C. So I can say angle ARC, angle arc, is congruent to angle C, because if it's isos, then I have two congruent angles. But when I mark it, I notice I already have that mark over here. So then by transitive on the angles, I have angle arc congruent to angle K, right? You can see the transitive here and here to get me this. Well, now in this green F, these two are congruent. So if corresponding angles are congruent, then my lines are parallel. So now I can say AR is parallel to BK. Those are corresponding angles. If corresponding angles congruent, then the lines are parallel. Now I have the same side is parallel and congruent. So by that last reason, I can say BARC is a parallelogram if one pair of opposite sides parallel and congruent, then you have a parallelogram. Okay? If you would like to stop here, if you feel good about this, you can. I won't require you to watch the last example. I'm going to do it just for those of you who feel like you'd like to see another one, or if you want to come back to it another time, it'll be here. Example 3. NRTW is a parallelogram. So let's mark what we have here. NRTW. So this is the one that we have information on, that big one right there. Okay. We have NX congruent to TS, NX congruent to TS, WV congruent to PR. That's all given. And I'm trying to get this guy in here to be a parallelogram. Okay, so I'm working on the yellow one. The green is the one I know. All right, so what properties of that green parallelogram will help me? Well, I'm looking at, I have all these little pieces congruent, so I think I'm going for opposite sides. I'm going to say WT is congruent to NR, because then I'm seeing some overlap. And I'm also going to say WN is congruent to TR. If parallelogram, then opposite sides are congruent. That came from the green, but now I have all this overlap, so I think I can subtract. So on the top and bottom, that would get me VT and NP. And on the sides, it would get me WX and SR. If congruent segs subtracted from congruent segs, then the differences are congruent. All right, well now I'm looking at triangles because these sure look congruent and these sure look congruent. What other properties of parallelograms would be helpful? Well, you can look back at your list. I hope you're realizing that opposite angles would be useful here. I'm going to use both pairs, so I can say angle N is congruent to angle T, and I can say angle W is congruent to angle R. If parallelogram, then opposite angles congruent. That will enable me to get my triangles congruent. So I have triangle XWV, that little guy, congruent to triangle SRP. And then here I have the left and the upper right there. That would be triangle XNP, congruent to triangle STV. And that's going to be side angle side. But now the question is, now that I have these triangles congruent, what corresponding parts will help me on the yellow? Hopefully you can realize we can just use opposite sides, right? So if I get XV congruent to PS, and if I get XP congruent to VS, running out of congruent markers, that's from my triangles. So if triangles congruent, then corresponding parts are congruent. Once those are congruent, I have both pairs of opposite sides congruent, so I have a parallelogram. XPSV parallelogram. If both pairs of opposite sides congruent, then I have a parallelogram. So there's one more example.